Okay, to do this problem, you could do it the way that I prefer to do it, which is the way I did it in the previous problem, or you could do it using integrating factors. I'm going to do it using integrating factors. But before I do that, I'm going to write this equation into standard form. So I'm going to write it in the form x prime plus t plus 1 over tx is equal to 1. Okay, so remember, for the integrating factor, the idea is we want to find an integrating factor. Usually it's called mu, and we want mu x prime, which by the chain rule is by the product rule is mu prime x plus mu x prime. We want this to equal mu times the left-hand side of the equation. So we want this to equal mu x prime plus mu x t plus 1 over t. Okay, and so now the equation that we have, well, those two terms cancel, and so what we want is an equation that satisfies mu prime x equals mu x t plus 1 over t. The x's cancel, and now the equation that we're left with is mu prime over mu is equal to t plus 1 over t. Now notice how similar this is to finding the solution to the corresponding homogeneous equation. So the two methods really aren't that different, but when you talk about it in terms of finding the solution to a homogeneous equation and then adding a particular solution to the non-homogeneous equation, it makes more sense, and it's a more comprehensive approach when you look throughout the entire course. Anyways, the left-hand side is log mu prime. This is equal to t plus 1 over t, and this is just 1 plus 1 over t. And so now this tells us that log of mu is equal to t plus log of t plus c. And so the integrating factor is mu of t is equal to t e to the t. And remember, we just need one integrating factor, not every single integrating factor. We just need one, and so we can take c to be equal to 0. Okay, so the integrating factor is mu of t is equal to t e to the t. Okay, so what's the whole point of that? Well, let me erase this. The whole point is that mu times x, the derivative is that the left-hand side, is that when I multiply both sides of the equation, when I multiply both sides of the given equation by mu, the left-hand side is the derivative of mu times x. Okay, so if I multiply this entire equation by the integrating factor mu, the left-hand side is mu times x prime, and the right-hand side is equal to mu. Okay, so what is mu? Mu is equal to t e to the t, so this tells me that x times t e to the t prime is equal to mu times the right-hand side, which is just t e to the t. Or in other words, this tells me that x of t times t e to the t is equal to the antiderivative t e to the t dt plus c. Okay, so this is an integration by parts question or integral. So let me just come up over here and do some side work. So u is equal to t. This means du is going to be equal to dt. V is equal to e to the t, dv is equal to e to the t dt. So this means that v is equal to e to the t. So uv is going to be t e to the t minus the antiderivative of v du. So e to the t dt plus c. So this is equal to t e to the t minus e to the t plus c. And so if I divide both sides by t e to the t, I get x of t is equal to 1 minus 1 over t plus c over t e to the t. And notice that if you had not put that integrating factor there, if you had not put that constant of integration there, you would not have ended up with this term, and that just would have been a completely different solution, or completely different function. So that constant of integration is important. Don't forget it. So that was this problem using integrating factors.